first terminology is point. So how can you explain point?
A point can be like any point, like on a graph. It can be a point on like a segment, like one from one end to another. It can be a point.
Means any dot, right?
Yeah.
Right. Suppose I'm writing point C. So what would be the point? Point C. Got that? Understood?
Yeah.
Got it? Next we have line segment, right?
I know what a line segment is.
Yes, you can tell me what is line segment if you know.
It's like two points connected with a line.
Yes. Can you explain two dots? You said it ends with two dots. What does that mean?
So
You're right, that line segment is having two dots, right?
yeah. So like if there was a number line, so like that goes on infinite, the two endpoints would be in that region only. So like for example, if it starts from one, it cannot go below than one, and only be in that region for one from to the other number what you choose. Like
Yes, very good. Means we cannot extend the line segment, right?
yeah.
Yes, good. Next is from either side, right? When we talk about line segment means it is having two endpoints, and it's not that we can only plot line segment horizontally, we can plot it vertically also. Okay. This is horizontal line, right? Next is
Yeah.
vertical. Means either way you can plot the line segment horizontally or vertically. If you plot any line segment vertically, that would also be called line segment. Got it?
Yeah.
Next
Okay.
is line. What is line?
A line is like it's just like any line without any like region or endpoints. It's just a line.
It's a line only. You are right. So we will be making arrows, right? Since
Yeah.
it doesn't have any endpoints. Endpoints means you can extend it to infinity from both sides. Got that? That is called
Yeah.
line segment. That is the only difference between line segment and line, that when we talk about line segment, it is having two endpoints, but when we say line, means it doesn't have any endpoint, right? From either side, you can extend the line. Then we have ray. Okay, how can you explain ray?
So array can be like, so for example, array can be, so it's similar to line segment, but so first the endpoint you have to choose, for example, a one, and then you can extend the array to infinite, either to positive or to negative.
Combination of, you want to say combination of line and line segment, right?
Yeah.
It is having both line and dot, right?
Yeah.
Arrow and dot, right?
Yeah.
So what would be that? Dot and arrow.
Wait, there's two types of array though.
Sorry,
There's two
but you
types of.
yes. Can you explain what are they?
So line array is the solid line array. So it means like so the number like you start from, like for example one, it means it is not included, and
Yes.
the other line array is like a hollow a circle, which means the number is included where you start from.
Okay, good. And have you understood this one, Ray?
Yeah.
Okay. Next is, you are right. The types are correct. And next one is intersecting lines. Okay, how can you explain intersecting lines?
It means like when two lines are intersect at one point, so like at the middle or like any section of a line.
That is
Two lines.
called intersecting. Yes, you are right. And it doesn't have to be any, means it doesn't need to have any center point only, right? Means it's not
Yeah.
mandatory that every time it will be having a center point.
Yeah.
If
It
I
could be
if I am
anywhere.
starting like, yes, it could start from any point, right? Any intersecting point. So if I make such, can you see the second figure that I have just drawn? This
Yeah.
thing. This would also be the line segment. Sorry, intersect, not line segment, intersecting
Yeah.
line. Got that?
Yeah.
Okay. Now I am making one more line over here. So you can tell me whether it is a line segment or not. Okay. Okay. Now, what do you think? Are these intersecting lines or not? Not line segment, sorry, intersecting lines or not?
Well, so these are just lines.
Yellow ones, yes. Are these intersecting or not?
Yeah.
How
So
come?
they are just intersecting.
Since you can extend them, right?
Yeah.
And once you will extend the line, it would be intersecting. Good. Next is, next we have, I hope you have understood this much, right? Next we have parallel lines.
Yeah, I know what parallel lines are.
Yes, you can explain.
So they're like parallel lines are like so for example like one set of parallel lines include two lines that can never meet and like go on for infinite.
Yes. You said never meet. This is the proper
Yeah.
word. They never meet, right? They are called this thing parallel lines. Also, what is given here in equal distance, right?
Yeah.
Right. When we talk about parallel lines, what is called that whenever two lines will be having equal distance, that is called parallel lines. And do they have any common point of intersection?
No.
Means they don't intersect, right?
Yeah.
They don't intersect. So first it says never meet. So what does that mean? Suppose I'm making two parallel lines. These are parallel lines. Now never meet means suppose if line is going like this and like this. So if it is meeting afterwards at a certain point means that won't be a parallel line, right? Or that
Yeah. Yeah.
since the distance is getting decreased, so we can say it won't be a parallel line, right?
Yeah.
Also, what is the second condition that we have written? Equal distance. Equal distance means the distance would be same from every angle, right? Got
Yeah.
that? From every point, right? They don't intersect. Yes, this we have discussed. They never meet, they don't intersect, means they won't be having any common point of intersection. So this is the difference between parallel line and intersecting line. That in when we talk about intersecting line, it does have this thing, common point of intersection, but parallel lines don't have, right? Okay,
Yeah.
curves. What do you understand from curves?
Curves.
Yes.
So a curve is like when a line is like it's like not straight, it curves, it bends. Like from a
Very good.
circle, the line
Yes.
a part of a circle, the line curves.
Yes. And see, two categories are there, simple curves, right? And what is simple curves we have, or you can simply say this thing, open and closed, right? Do you know what are open curves?
Yeah.
What can you explain?
So like a half a circle is an open curve.
Yes, very good. And closed?
Is a full circle.
Yes. And one thing I'll add, it need not be circle every time. It could be any
Yeah.
curve, right? Or that.
Yeah. It can be an oval if
Yes, means it could be a freehand curve also. It's not that you always have to make a proper circle or something like that. It could be any figure like this, right? So that would also be
yeah.
a curve. Got it? Suppose
Yeah.
I'm making a clouds like thing, right? So it is also having curves, but if I'm not joining, it would be an open curve, right?
Yeah.
Something like this, right? Okay, next is polygons. And what is the
I know
closed curve? What is the closed curve?
a closed curve. Sorry, I couldn't hear you.
Closed curve.
A closed curve is like when the line curves and ends and like it meets at the
Means
from the first point.
yes, very good. You are right. Means the beginning point and the end points are same, right?
Yeah.
Means it will end where it had started from. Good, very good.
Yeah.
Next is polygons. Okay. What do you understand from polygons?
Polygons can be any shape. A polygon can be any shape, but it cannot be a polygon if it has a curve or like if any lines are intersecting from another line.
You are right. Means for any figure to be considered polygon, it needs to have what?
It
Lines,
needs to
right?
be yeah.
Lines, vertices, and diagonals, right?
Yes.
Got that? So if I ask you, okay, is circle a polygon? What will you say?
No.
Why? Can you give any reason?
Actually, yes.
See, we have discussed polygon is the figure that is made from lines, vertices. Vertices means it needs to
Yeah.
have corners, right? It needs
Okay.
to have
So
corners, right? Okay. I'm highlighting
yeah.
this line. Okay, it needs to have corners and diagonals. Now think of, will it be a polygon or not?
No, circle won't be a polygon
Yes. Why now? Can you explain?
because it's a closed curve, so it cannot be a polygon. It
Yes,
has
very
no.
good. Means any, yes, you are right. Means any figure having curve won't be considered polygon. Got it?
It also has to be a closed shape, so it can be like it cannot be like a half square or something.
This point means this is the main point that you have said, that what you said, closed figure. It needs to be a closed figure. Very good. Though circle is also closed, but since it is not having any line, so we cannot say that this would be a polygon, right? So
Yeah.
first condition, what we said, it needs to have lines. Then vertices. Vertices are what? Corners, right?
Yeah.
So when you talk about one corner, we use the word vertex, right? And
Yeah.
plural is vertices. And what as I said, diagonals. It needs to have diagonals also, right? So that would be considered polygon. Suppose I am taking any quadrilateral figure, square I am taking, rectangle I am taking, or any figure that is joined with something like this. Means what that?
Yeah.
Made from rectangle square, or two rectangles are joined, so that would also be considered polygon. Okay, next we have angles. Okay, what do you understand from angles?
So angle is like the. So like is like the measure of like the corner. So like the inside of the corner vertex. It's like the measure
Very
of
good.
the. Yeah. So
Means whenever two, yes, yes, you can explain if you want to add something.
yeah. So like a square has like on one vertex a square has 90-degree angle because it's in the like yeah.
I got you what you are trying to say. Means it needs to have a common point, right?
Yes.
When two rays are joined with a common point, that is called angle, right? You
Yeah.
have given example of scale. So you are telling me is whenever we will be making any sphere, and if we pick up any corner of the sphere, that would be the angle, right? That's what you want to say.
Yeah.
Am I right?
Okay. Right.
Yes. See, now angles we said whenever we join any two rays with a common point, that is called angle, right?
Yeah.
So this would be the angle. See, I'm making it again, right? So what would be the angle here? This thing would be the angle.
At the
Right.
vertex.
Yes, and we can label it O A B, right? So how can I, yes, how can you pronounce this angle?
OAB.
What,
It's either
sorry?
OAB or BOA.
Angle.
Oh, so wait, degree, like you mean?
No. Means how are you going to label the, sorry, labeling we have already done. How you are going to name it?
Oh, so like angle O.
Angle, oh, very good. Means whatever would be the center alphabet, that would be considered angle. So if I have to name it, I'll be naming it as AOB, right? Means this center point, this alphabet needs to be at the center of both alphabet A and B. Got it?
Yeah.
That's how we cannot say OAB, or we cannot say A, since they are not at the center, or you can say they are not the this thing vertex. So vertex needs to be in the middle, right? Good. Next we have interior point and exterior points. Interior points and exterior points.
I know what interior and exterior points are.
Yes, can you explain?
So interior points is like sorry, just a second. So
Yes,
interior
yes.
point is like the like you can say angle, for example, is like interior, like inside of an angle, and exterior points is like outside of the angle.
I'm plotting the in points in the previous figure, so you can tell me what would be the interior point and what would be the exterior point over here, right? I'm plotting it in green,
Okay.
right? Green, and one in blue I'm plotting. So you can tell me. Yes, can you see the 2 points green and blue in the previous figure?
Yeah.
Now can you explain what is interior angle, interior point, and what is exterior point?
Interior point is like the green dot is the interior point because it's
Yes,
inside
very
of
good.
the polygon, and exterior point is like one outside of the polygon or any line intersection.
Yes, very good. Means intersecting point, inside point, right? So what is that? That is lying between the rays, right?
Yes.
So now can you tell me which one is restricted?
What do you mean? Like,
We talk about interior point and exterior point. They have some restrictions, right? So which one
yeah.
is more restricted, or which one is restricted?
Um. Both are equally right? Restricted.
Restricted means you they have some specified region, right? Beyond which
Yeah.
they cannot be plotted. Understood?
Yeah.
So which one is having restricted area?
Green is having the inside a restricted area, and blue is having the outside
Yes,
restricted.
yes. Outside. What words we have used here? See, interior points and exterior points. So when we talk about interior points, there is restriction, right? Or it is restricted. But this one is not restricted. Got that?
Yeah.
Means you can plot this exterior point anywhere outside the figure. But when we talk about interior point, it has to be over there only, where it was, right? Next
Yeah.
is next is triangles. Okay, triangles.
Triangles.
Wait, I'm inserting a page here, right? Till
Yeah.
then you can think triangles. Triangles. Means you can explain whatever you understand from triangles, right?
So there are like many types of triangles. So like to be a triangle,
Yes.
it has to have a 180-degree in total angle, and it has to
Yes.
be have three sides and three vertex. Then there's also isosceles triangle, so which is like a 90-degree triangle, and there's also I forgot other triangles.
It's okay. But there is just one thing that I want to correct. You said vortex. It is not vortex. That would be called
Vertices.
vortices, right? Yes, yes. Since you have
Okay.
used three points, right? You said you are
Yeah.
right. It is having 3 points. So whenever you will be saying more than one, so it would be vortices, right? So
Yeah.
you are right. Very good. You said triangle is a closed figure having 3 sides. Very good, which is correct. Then you said it is having 3 corners. That is also correct. Vertices. Also, it would be having 3 sides also, right?
Yeah.
So can you name them? See, I'm labeling, then you can tell me the lines, right? Line segments. I'm plotting. Also, see, whenever we label any diagram, either we go clockwise or anti-clockwise. Got it?
Yeah. Okay.
You have to follow the certain pattern. So if you clockwise means you have to end in that order only. Or either you can, what I said, either you can plot it, label it, sorry, clockwise or anti-clockwise. Okay, now can you tell me the line segments that is there?
Yeah. So first line segment is AB, then BC, then CA. Yeah.
Maybe. Yes. And how are we going to write the line segments? Generally, whenever we name the line segments, we like write it like this AB, and we would be plotting a bar type thing,
Yeah.
right? Means that is not actually bar, that is a line segment
Yeah.
representing this lines. This slipping line is representing line segment, right? And next you said BC, right? So for this also on the top I am making one slipping line and CA. Good, very good. And what are the vertices? These are all what? Line segments, right?
Yeah.
Or you can say sides of the triangle. Sides word we can use, right? And what else is there? Yes, I'm asking about vertices. Can you name the vertices over here?
A, B, and C.
Yes. And can you name the angles over here?
Angles is so first angle is CAB, then
Yes, very good.
ABC, then BCA.
Yes, very good. Angle A, angle C, angle B. Good. Next we have quadrilaterals. Okay, now what do you understand from quadrilaterals?
So quadrilateral is like it can.
Okay, okay, wait. Sorry for interruption. I wanted to ask you one more thing. Is triangle a polygon? Yes.
Yeah, it is
Is
a polygon.
triangle? Yes, very good. Why
Okay.
is that so? Why is that?
Because it has line segments and also it is a closed shape. Closed shape.
It is,
Yeah.
yes, it is a closed shape. It is having lines and vertices also. Good, very good. What is quadrilateral?
A quadrilateral has four sides, four vertices, and a total angle of just
Yes, very good. A quadrilateral has four sides, four vertices, and what else you said?
and a total angle of 180. Sorry, 360 degrees.
Sum total. Angle sum
Yeah.
property of quadrilateral, you are saying. That is called angle sum property, right? Angle sum
Yeah.
property of quadrilateral, yes. It is 360-degree. Good. Next is what quadrilateral I have made over here is that is
Square.
here, right? You can go with any of the quadrilaterals. Quadra means having four sides. So you can go with rectangle also or parallelogram like that. Next we have adjacent sides. Yes. Adjacent sides. And what else is given in the book? Adjacent angles. What do you understand from these two words? Adjacent sides and adjacent angles. Whatever you understand that you can tell, right?
Yeah. So adjacent side is like, so for example, wait, can you write the ABCD on the square? I can tell you.
ABC. Okay, yes, yes. Means I should label it, right?
Yeah.
That is called labeling. So how will you say label the diagram, right?
Oh,
Use
okay.
the word label. Okay. I'm labeling it. Yes.
So adjacent sides. So like adjacent sides, like for example, AB adjacent side can be BC or AD, and adjacent angles is like So for example, angle B adjacent angle could be C or A. So like it's like the angle beside or like the side beside of the.
Yes, very good. Suppose we can take example of a class. Suppose two students are sitting on one desk, right? Desk.
Yeah.
Understood? So on one desk, sorry. So if they are sitting beside, one student is sitting beside the other, so we would say that they are adjacent to each other, right?
Yeah.
Sitting next to each other. Yes. What proper word we can use? Sitting next to each other. Or when we go with the
Beside.
diagram in geometrical term, what we can say they would be having something in common, right? When we say
Yeah.
adjacent sides. So what do they have in common? You said AB and BC. would be adjacent sides. So why are they adjacent? Because they have something in common, and what is common over there? That is B. Got it?
Yeah.
Then you said BC and CD can also be adjacent to each other. BC and CD. Now, why they are adjacent? Now, how can we say? Because BC was already adjacent to AB. So, how can BC be adjacent to CD? Because they are also having something in common, that is C. So, whenever two sides will be having some common point, they would be called adjacent sides, right?
Yeah.
And what are adjacent angles?
Adjacent angles is like, for example, angle B. Its common angle next to each other is angle C or A.
Angle B is having what adjacent angles? Angle A and C, right? Because they are sitting next to each other, right? Or you can say, what do they have in common? When you said, when we talk about angles, how can we say that they are adjacent?
Because they intersect in with angle B.
Angle A is adjacent to angle B, right? Because they have a common line AB. Got that? What do they
Yeah.
have in common? A common line AB, right? That's how we can say they are adjacent. Means we always have to look for something common. Okay, now if I talk about, good, very good. Now if I talk about opposite angles, how can we explain them? Opposite angles. Hello?
Yeah.
Yes, can you hear me?
Yeah.
Opposite opposite angles.
So opposite angle is like it's not next to each other. It's the opposite. So like opposite of angle C is angle A.
Means they have nothing in common, right?
Yeah.
Right. So can you explain, can you label or can you name opposite angles? Wait, I'll scroll back for you, right? You can, from there, you can tell me.
So opposite angle of B is D, or opposite angle of A is C.
Yes, very good. Because they have nothing in common, right? So we will be writing angle A is equal to angle C. And what other pair is there? Angle D is equal to angle B. Very good. Then we have next 16. Opposite angles we are done. Sides we are done. Okay, what are opposite sides?
It's like it has nothing, like it has no sides in common, so it is opposite.
You're
So
right.
angle, yeah.
Wait, I'll again scroll back.
Okay.
Yes. What are the opposite sides here? Is the board visible?
Yes.
Okay, what opposite sides are here?
So AB is opposite of DC and AD is opposite of BC.
Because they have no point in common. Good, very good. AB is opposite to DC. Good. Next we have circle. You know, you can think of this and then you can explain how can you define circle, right?
Yeah. So a circle, so it's a closed curve, for example, and the total angle is 360 degrees.
What else is there?
And then
Yes, you can go through the book and you can tell me.
okay.
Are there any other things in the circle that need to be discussed?
A circle, you can like find the circumference, so like the perimeter around the circle,
You are right.
or the area.
Yes. So see, first we are having center point, right? Circle always have some center point, right? When we talk about, see, I'm making lines. You can, if you know the those lines, you can tell me what are they, right? First line I'm making is this. O point, right, is the center point, and this. Now, can you tell me what is that? Red line.
So line OA is the radius.
Yes, very good. Means, how can you explain radius?
So it's like the point A is like meeting half of the circle.
Yes,
Center something.
means whenever, yes, very good. Whenever we join any 2 points starting from center to any point on the circle, that is called radius, right? Means it's not that I can make a radius over here. I can make radius on any part of the circle, provided it should
Yeah.
start from the center, right? This, right? Tire
Yeah.
something. If I'm making tire sort of, right, thing, so that would be, that all would be radiuses, right? Radius. Okay, next what is given? Diameter. This is
A
radius, you
diameter.
said.
Yeah.
Yes. What is diameter?
So diameter is like from one end of the circle to the other end. So it doesn't meet at the center point. It means one end from the other end, and to find a diameter, we can multiply radius by 2.
Means any line that divides the circle into two halves, that would be diameter, right?
Yeah.
Am I right?
Yeah.
Into two equal halves. This is the condition for diameter, right? Means whenever
Correct.
2 points will be joined, and it would half the circle, that would be diameter. So how, if suppose radius is given to you, so how you can say what would be the diameter? Suppose I'm giving radius 5, so what would be the diameter?
Uh, Radius 5. So 10.
Yes, very good. Either you can say radius is half of diameter, or you can say diameter is double of radius, right?
Yeah.
Fine. That is right. Next we have, after radius, what is there in the book? Okay, sectors, segments. Do you know what are sector and segments? And chord. Okay, I'm writing the terminology according to the syllabus, right? First is chord, chord. We pronounce it as chord. Then we have segment, and then we have sector. If you are familiar with these terms, you can explain.
Wait, segment like a line segment?
Sort of.
Uh,
But here I haven't used the word line.
yeah. I don't know what chord means, but I think sector means like a section, like a section of something, and segment is
Yes,
like.
yes, you are. Yes. Very good. You are closer to that. Very good.
Oh,
Let's
okay.
discuss. Good, good. See, what is chord? First, I'll make one circle, right? So that everything is clearly visible, right? Now, when we talk about, better I make it again. Okay, what you said, code would be what? Code was what? Yes, what was the code?
Oh, wait, sorry.
Can you explain? Can you explain the code?
Chord is you know what chord is?
Code you don't know? Okay, that I'll explain. Wait, I'm trying to make a proper circle for you here, right? Is the blue circle visible?
Yeah.
Okay. Now let's discuss the code. Whenever you will be joining any 2 points on the circle, they need not be on the, what we can say, from the center, right? This would be a code.
Okay.
Got it? Means whenever you will be joining 2 points on the circle, but they need not be originating from what? From the center or passing through the center, that line would be your code. And how we can label them? We can call it A and B. Suppose I am labeling it A, and B. Now, from this, as you said, this is segment is a part. From here, you can easily tell me what is segment. This you said this is the code, right?
Yeah.
Now, segment.
It's like from one part to another with like equal distances, I think.
Equal distance.
I think, yeah.
Okay. Okay, I'm telling you one statement, right? Then you can tell me. Segment is the region between arc and chord. Now, can you tell me what would be the segment here?
Oh, okay. So
The lower part of the circle or the upper part of the circle?
a segment, like the upper part of the circle.
Yes. Basically, both would be the segments, right?
Yeah, both.
But since are going with this AB code, so we can say this would be the segment part, right? Understood?
Yeah.
I'm asking about this much region. So this part would be your segment. Means any region between chord and arc, right? So that would be the segment. Okay, now what is sector?
Sector is like the whole part.
Okay, now I'm making a center point here, then you can explain. Also, I'm giving you one definition. Sector is formed through arc and center, through radius, you can say.
Okay, so
Then I'm writing definition for the segment, right?
yeah.
Yes, can you think of sector? Okay, so see, I'm giving you a very good hint. Okay,
Okay.
suppose I'm making one circle here, or you can say pizza, right? Now, what I'm doing, I'm not cutting the slices in quadrants. I'm cutting it. We there are suppose there are six people eating that pizza, right? So I'm cutting it into six parts. One, two, three, four, five, six. Now, can you explain what is sector?
So it's like so sector is like the slice, like part of the whole pizza.
Yes, yes. Yeah, either you
Okay.
can say slice. Yes, very good. Either you can say slice of pizza, right? And why are we calling it slice of pizza? Because we are not cutting it into quadrants. Okay. Had I
Yeah.
cut it like this, suppose one more pizza I'm making, right? Okay. Now can you tell me would that be a sector or not? I'm
No.
cutting it into four
Oh,
pieces, right? So this would be a quadrant, right? Because it would be
yeah.
giving a 90-degree angle, right? This would be
Yes.
considered quadrant. And since the previous figure here, we are not getting any 90-degree angle, so we would call it sector, right? So slice of pizza would be your sector.
Yeah.
So how can we call it in geometrical terms? The region that is formed with the arc of the circle, right? And with the radius. That is
Yeah.
called sector. Am I right? See, I'm
Yeah.
highlighting it in white. So this part would be sector. So what definition you will be giving? Okay, the region between radius or the region formed with radius and arc of the circle, that is called sector, right? So suppose C and D. And what is the arc? Can you explain what is arc?
Arc is like arc is the curve of the circle.
Any curve, right? Suppose here you are taking CD, right? So that would be the arc. And what is the sector? Region formed with radius and arc, right?
Yeah.
Of the circle. That would be called.